Hi everyone and welcome back to the multiverse of 100 plus data science project series. In this video, I am going to be discussing about the Big Mart Sale Predictions using Python and machine learning. So let's have a look at the demo application first. So that's our demo applications called the Big Mart Sale Predictions using machine learning and how the interface actually look like. You can give your input features and if you're clicking this predict button, it will give you the predictions. So let's try to test it out here. So let's say giving here below let's say 677, let's say 19.35, and let's giving here the item fat content, let's say 1, and let's give it here the item visibility, let's say 0.66, and item type, let's say give it here 10. Just I'm going to giving some random value from my data sets, and let's say MRP, let's say 17.90, and item content, let's say 2, and let's giving here one where, so let's say 2007s. Okay, and after that we need to giving here our outlet side, let's say giving here 2, 1 and 1. I just taking it the data from my data sets for the predictions. Let's give it the predictions, and I got here predictions called 2191.3066. So that's our predictions cells, how it will work. So in this tutorial we're going to be building this full application from the scratch. So बिना किसी तरह हर हर महादेव बोल के start करते हैं tutorial. So in order to creating the Big Mart Sale predictions, you're going to use the dataset from the Kaggle, and that's the dataset Big Mart Sale forecast. And you can also read the features. So how many features are available inside a dataset. So the dataset in the formal CSV, you can see here it having two files, train.csv and the test.csv. So I'm simply going to download the dataset from here by clicking this button. So after downloading, we got here one zip file, and after extracting, we got here the train.csv file and as well as the test.csv file. So for this coding purpose, when using here the Jupyter Notebook, you can using here the Google Colab or PyCharm itself. And already creating here an empty IPN file, I'm simply going to opening it out. So that's our empty notebook. Now I'm going to starting here the coding part here. So first thing first, I'm going to importing here all of the important library. First, I'm going to importing here the pandas. So let's say import pandas as pd, and as well as I'm going to importing here the numpy as np, and also importing here the matplotlib plotlib.pyplot as plt. So those are the basic library for the machine learning purpose. So using pandas, you can load the dataset from the directory as well as you can do the visualizations. And numpy is nothing but for the calculations, matrix calculations, and this one for visualizations. And yeah, you can also importing here another visualization library called Seaborn. So using Seaborn, you can plot like more unique types of plot, just like this plot, distribution plot, count plot. You can do that, as well as you can use the EDA or called the exploratory data analysis using this library. That's the SNS. Now shift enter. Okay, now you can see here some warning. It's happening because I am using here Python 3.8.5. Some kind of warning may be happening. You can also ignore that. So for that, you can using here, let's say import warnings, and after that warnings. Oh, thoda mistake. Warnings dot filter warnings, and after that you can simply go to ignore that. Ignore. Yeah, now you can see our warning is gone. Now what I'm going to do is simply going to load the dataset from our working directory. So your IPN file should be in your working directory. Now what I can do, I'm going to using here pd.read underscore csv. So I'm going to giving here a path, it's called train.csv. Okay, csv. So it's simply going to using here our train.csv, not the test.csv. Okay, this purpose only. So it's simply going to working on the train.csv file. So what I can do, let's make it a variable called data. Okay, that's our data. Now let's taking the data. So data.head, so it will give you 5 columns of your data set. So you can see here, this is our data set, how it look like. And you can also see the shape of your data. So let's say data.shape. So this is the how data shape look like. So it having the 8,522 row and 12 columns. So columns is nothing but the features column. Okay, and 8522 is nothing but my data. Okay, so this is how you can actually load your data set using the pandas library, as well as you can checking the shape of the data using data.shape. Now let's checking the information regarding our data set. So let's say data.info. It will actually giving you information just like the data types and otherwise null count. That's mean if there are any missing value or not. Okay. Now see in the item void it having some missing value. I can see that because our data shape is nothing but 8522, right? So that's mean it having some missing value, as well as here also having some missing value. As well as you can see here in these sections, you can see here the objects is nothing but categorical data to handling this out, as well as float 64, that's the numerical types of data. And you can see in 64 numerical types of data, you can see the data type as well as in the informations, I mean data.info. So using that, you can checking this data informations regarding that. So now we're going to checking that is there a null below or not. Yeah, we can see that it's having null below. Yeah, let's checking this out. Is another technique called is null dot sum. Okay, so you can see it having some null value inside the item weight as well as the outlet size. Okay, it having some missing value. So to handling this missing value here, to handling those missing value. Okay, so let's checking this out. Is there any duplicate value or not? Because the duplicate value may be heavy on your machine learning model as well. So let's say data dot we can using here duplicate as well as you can do the sum here. Yeah, so you can see here we having zero duplicate value. That's why we don't need to handle the duplicate value as well. So just need to handle in the null value here. Okay, so let's say filling the missing value. You can say filling the missing value. Okay, so let's make it markdown. Okay, markdown. You can also make it heading as well. Okay, heading. Okay, so filling the missing value here. Now see we having two missing value. It's nothing but if I checking this item weight having 1463 missing value, and this is nothing but 1464. And if I checking for the outlet size, it's nothing but 2410s, and is nothing but the objects. Okay, that's mean it's categorical types of data it's having here. Now the question is, we have two types of data type, two columns are which are having the different types of data type, which is the float and as well as the objects. I mean the categorical data, or you can say string. Now, how can we fill the missing value? How can we fill the missing value? If you have any numerical types of value, okay, that's mean you can filling with mean of the value. You can filling with the mean of the value. Otherwise, you can also remove this shell, remove this whole column from your data set. Now let's say if I going to removing this all of the data from our data, so our data should be low, our some data should be lost. Okay, so it's not a best practice to drop the whole data. Okay, because it having so much of data. If there are let's say missing value, let's 7 missing value, so we can simply dropping this out. But there are so many data, so we can't. Okay, that's mean to fill in the missing value. So you can fill in the missing value with the mean for the numerical data. Now for the categorical, we can fill in the missing value with the mode, with the mode, with the mode. Well, yeah, for the categorical you can using here the mode technique, and for the numerical you're going to apply here the mean of the whole data frame, mean of the whole data frame. Okay, so in the numerical type it's nothing but which column is nothing but the item weight. So you can copy this out, this item weight. Okay, item weight is nothing but my numerical one, and this outlet size is nothing but my categorical one, I mean the string one. So what I can do is simply going to fill the missing value with the mean for the item weight as well as the categorical for the mode. Well, now let's take in some shell. Okay, well, so now what I can do, first I'm going to go on the data, that's our data, and after that you're going to go inside my item weight, this item weight, and I am simply going to filling the missing value. So let's say fill in the missing value with the data of item weight dot mean. Okay, well, and I'm simply going to make it implicitly true so that it can place the filling, I mean nan value with this item what mean value. Otherwise, if you're not giving this implicitly true, it is creating a extra column for that. So shift enter. Now if I need checking this one, this is null.sum, then you can see just to wait, then you can see it's don't have any null value. That's mean we're filling the missing value with the item weight, with the item weight. Now we need to fill in the missing value as well as the outlet size, so this is nothing but one categorical data, right? This is nothing but categorical data. So what can we do actually? We can checking that the data of outlet size, this outlet size. Yeah, here you go, this outlet size. And we can checking this unique value. Okay, unique value. Okay, so see, we're having some unique value called medium, then as well as nan, which one is missing value, and high, and as well as small. Now let's say I am going to taking the mode. I'm going to taking the mode of the outlet size. Just to wait. So I'm going to taking the mode of the outlet size, mode of that. So see, I got here mode is nothing but medium. Mode as a medium. Now let's say I am trying to fill in the missing value, this kind of missing value with the medium, with the medium, with the whole all of the medium, because yeah, I got here the mode as a medium. Now there should be some value is which one is correlated with the high as well as the small. Yeah, that can be possible. Let's say I have 2410 value are missing. Now I am simply going to filling the missing value with the medium. Is it okay? Is it okay? No, it's not okay. So see, you have three types of value: medium, high, as well as the small. That means some value should be correlated with the high, some value should be correlated with the smalls, with the smalls. Okay. So what you can do, you can simply go into creating here one pivot tables based on the type of the data. Yeah, we can taking this outlet type or outlet location type, just you know giving here one values based on the columns. You can checking that how it actually correlated. Okay, so if we're checking this one, let's say outlet type, just to write, we can lacking this one, let's say data, and after that we can checking this outlet type, just to write dot unique. So you can see supermarket 1, supermarket 2, grocery store, the supermarket type. So using this one, we can actually compare the medium, high, or small. Okay, yeah, we can do that. So what you can do, you can simply go into creating one pivot tables. So let's say data dot pivot table for comparing these ones. So let's say values equal to, let's say outlet size. So बाहर में शायद बारिश हो रही है. Okay, outlet size. Then we have the columns. Then what again? We simply going to giving here the outlet type. You can also giving here the outlet location type as well. Based on the location type, you can actually giving here the high. You can compare in the high, the medium, as well as small. You can do that. You can do that. So what I can do, we can checking this one. It's your job to do that. So equal nothing but the outlet type. Okay, that's my columns. And after that, I am simply going to giving here on aggregation functions. So aggregation function should be the mode. Simple. So aggregation functions. Aggregation function is nothing but my, let's giving here on lambda functions for that. Lambda x, then we can giving x colon dot extra mode, and simply we're going to take in the first index for that. Okay. So it will actually creating here on pivot tables. So it's nothing but the mode of the outlet size. So let's say mode of outlet size. If I try to checking this one, mode of the outlet size, this is nothing but on data tables. Now you can see for the grocery store, it having the small. For the supermarket one, it having the small. I mean, which are the data? It's nothing but the outlet type is nothing but the grocery store. It will filling all the data with the small. And which one is supermarket 2 is filled with the small, and supermarket type 2 is nothing but the medium and the medium. That's really based on the outlet type. Based on the outlet type, it will try to fill in the missing value. It will fill in the missing value. You can also using here the location type, but I think that for the Big Mart sales, supermarket or the grocery store should be the best column for creating the pivot tables. Okay. Now what I can do, we have the values. Now we can simply go into fill in the missing value for that. So let's try to checking first. Let's say data of outlet size. So outlet size. Okay. Dot is null. Okay. And that's the missing value. So let's taking it out. Missing value. Yeah. So those are the missing value for the outlet size. So now what I can do, let's check in the count of that. Okay. So let's say, yeah, you already count that. This is another way for counting the missing value. Yeah, see how many missing value are nothing but the false and how many are the true. That's mean those are the number are the missing value. Now what I can do is simply going to replace this missing value. Okay, so for that you can using here the log functions. So let's say log functions, and inside that you can passing here a missing value, this missing value. Okay, missing value, those are the missing value. I'm simply going to fill it with. So using based on the outlet type, type. Okay, based on outlet type, and I'm simply going to apply here the lambda functions. So let's say apply, and after that I'm going to be using the same technique, lambda x and mode of outlet type. That's the mode of outlet size, so which are having the based on the supermarket or the grocery sale as well. Okay, so outlet size, and simply going to passing the x. Okay, so that's it for actually filling the missing value. Okay, inside my data. So what I can do using the shift enter, now you can see this our outlet size. Okay, just our outlet size, how it actually look like. Now we can checking this. Let's say data dot is null, not in null actually, is null dot sum. Okay, yeah, you can see it also having the null value as well as I think we got in the missing value. Data dot outlet side is null. I think I need to taking this out at here. Is also same, is also same. And after that we're counting the sounds, and we're simply going to passing here this missing value, and as well as you can passing in the output type, uh, output type here. Yeah, we need to also putting the same thing here. I mean, in the same variable we need to putting this on. Just say copy this out, and inside the outlet size, so that's why it's not happening. Yeah, we do it, but we're not actually putting here the missing value inside this outlet size variable. I mean, not actually giving here the locations the same value as well as. Okay, so that's why it actually gave me this kind of error. Now you can see it removed the error. That's mean we finally get the location of the missing value, and also filling with the outlet types, and after that it also replace them in the locations. They replace with the same location. That's why it's giving me this kind of missing value informations. Okay, now you can see we're removing all of the missing value from our data set. That's fine, that's fine. Now what I can do, we can check in the data to describe for checking the descriptions. Okay, describe, थोड़ा mistake हुआ है शायद यहाँ पर. Yeah, now it's okay, fine. So data to describe is look like that. You can give here the count, get here the count, the mean, the standard deviations, as well as the minimum, 25% percentile, 50%, 75%, the maximum. Now let's throw some EDA. Okay, called the exploratory data analysis. So exploratory data analysis. Let's pause for data analysis. Let's go on here and give it heading. Okay, okay, and here you go. Okay, let's try to do some data analysis based on this describe method. Okay, so these are the numerical types of value. So let's try to do it for the numerical one. So for the numerical data, we can do the distribution using the SNS.displot. So what I can do, you can using an SNS.set, and after that, let's making here plt.figure, because you need to giving here also a fixed size. So let's say fixed size, and as well as you need to giving him the size of that. So let's say 6,6, 6,6. Then we can using here SNS.distplot is nothing but called the distribution plot. Okay, and after that you can using here the data, and which column I'm going to giving it here first. So let's say giving it here the item weight, that's the numerical columns. Yeah, we also checking this at how can you actually using here the categorical column as well as for the EDA for the data analysis, right? So that's it. And now you're using here the plt.show, plt.show. Now this is nothing but the distribution for the item weight. Okay, let's making it out. So item weight distribution. थोड़ा mistake हो जाता है यहाँ पर. Okay, let's checking this out now. This the distribution how it look like, and you can see in the data at the middle, maybe the this is nothing but for the middles. So it's 25% and 75%, the 50% one. In the 50%, there should be the middle should be the 12 or something like that. If I checking this one, for the item weight, the minimum is this one, 4.55 is the minimum, and the maximum is nothing but 21. Yeah, 21. and 25% is nothing but starting from 9.31. So here you go, 9.31. I think so here from here, and the max 50% is nothing but the 25.8 12.85. That's mean this is the middle one, the 50% percentile, which one lies at 12. Something is nothing but the between the 10 and the 15, maybe 12. And the 75% is nothing but starting from 60. After 60, it should start from the 75% percentile. That means this is how it will look like. It's not, yeah, normal, not in normal distribution actually, quite like a squeeze down here. Yeah. So this is how your describe function actually work. So let's do the same thing for another one. Let's copy this on. And if I'm using here this item visibility, this one item visibility, and after that I'm going to using here this item visibility. Okay. Yeah, you can see how the distribution look like. It's look like this skewed in from here is distributed correctly, but after that it's not distributed as well. That's mean here you can see the data at the peak point is equally distributed. It's not a normal distribution, quite skewed here. If I'm checking this one, so you can see here for 50% 0.5, after 0.5, after 0.5 you can see here this is the middle point, and after that it will decreases, it will decrease. You can checking from it here, 75% 0.09, quite low. Okay, maximum is 0.32, 0.32. You can see 0.32, the maximum column for that. Okay, let's try to checking it for another one. Let's checking it for this item MRP. So here you go. This is how it look like. It's it's sometimes it will up and sometimes it will down. Yeah. This is how the item MRP look like. And now let's try to do the same thing for outlet stabilized year. So this is nothing but a year, so we can using the count plot as well as, so not distribution plot here, because this plot cannot be applied here. Okay, so we can using here the count plot for that. So outlet established here, so it should be the count plot. So count plot. So this is how the count plot look like. So in this case, as you can see, in 19085 the cell should be greater, I mean data should be, it having the more data for the 19085. Last number of data is nothing but in the 198, and all of the data should be are equals distributed. You can see for 199, for 2002, 2004, 2007, and 2009. So all of the data are should be in the same manner for the established error. So let's checking for the another one called uh, the last one called the outlet cells. This is the cells. I don't think you don't need to do it out. Okay, because this is the target column. Okay, and one more thing, it is the, is this problem is nothing but a regression problem or the classification problem. Yeah, this is the regression problems. See how the data look like, it is quite skewed, and after that, after 2000, the data is look like low. I mean more cells should be happening inside the sections 0 to 2000. Okay, yeah, that is how it actually look like. So it's better we can also uh, change this one. So item weight and item MRP distributions, there should be item MRP. So what a mistake for MRP, and as well as this is output outlet established here. It's called the count. Okay, count, and this is called the outlet cell. This is nothing but my target class. Yeah, we don't need to do it out. Yeah, let's try to show this up here also. Okay, so this is the distribution plot, the how the ADA look like. You can add it in your research paper that yes sir, this the data set is how it will look like, the distribution of the data set, and here you can see that you can add it in your research paper as the presentations. Okay, so now let's try to do it for the categorical column also. So how can you stack the category columns? You can stack the category column based on your data type. So you can using here data dot select d types, and you can include objects. Okay, so let's say take one shell here and checking here another way. So let's say data dot columns. See in here you have the columns, all the columns, but you can't identify that which one is a numerical column and which one is a categorical columns. Okay, so using this one you can do that. So let's say, and those are the data set based on my object. So now if I try to check in these columns, so columns, now you can see, you can get here all the columns. Okay, the first column is called the item identifier. If I check in this one, this item identifier is nothing but, it's nothing but one name, simple name. We don't need to, it's nothing but my item name. Item name FDF15, FDRC0, FDN05. It's nothing but the item. So we don't need to actually handling this out here. Okay. The categorical one. Yeah, we need to also handling this categorical one using the level encoder. Okay. But before that, let's try to do some data analysis on that. Okay. Is there any problem in our data or not? Okay, let's try to do the categoricals for the EDF for the categorical data. So what I can do, you can using here PLT again. You can copy this out, and after that you can using here. It's nothing but for the item fat content, so we can do item fat content count, because in the categorical column you can do the distributions because it's not a numerical types of data. So you can do as well as the count plot. So what I can do is simply going to making this with the count plot. Okay, so this is how it look like, item fat content, and in this case you can see here low fat and the regular, low fat, LF, regular. Okay, there should be some problem in the data. It's mean maybe the problem should be the data makers. It's nothing but the human error. They're making this low fat, L should be the capitals and F should be the capital, but for this low fat for the some data, it will try to making this low fat as the green. In the green section you can see here there's some doing some mistakes. That's mean it has just having two unique columns. It's nothing but the low fat and the regulars, and you can see REG, that's mean the regulars. That's mean you need to combine them or you can replace them. Okay, that's we need to do some calculations on this item fat content. So let's try to do some operations on the other data set, other things. Is there any problem on that? So let's item type, item type. So it's to be the item type. Okay. Okay, it's not showing up. Let's try to increase the size. So let's making 36. Yeah, now it's showing up. It's called dairy, soft drinks, the meat. Okay, let's try to in classic mode. Yeah, it's okay, fine. Household, the banking goods, snack foods, the frozen diet food, breakfast, health and hygiene, hardings, canned breads, stack foods, others, seafood. Okay, okay. There's not having there's not having some problem on this item type, so you can go for the next one. So let's try to do the same thing. Okay, it's better I can copy this out. Okay, okay. Let's copy this out. Outlet identifier. So you can give it here and try to check in this count. Yeah, you don't have any problem on the outlet as well, as you can see, no problem on here. So let's try to do the same thing for checking this one. Yeah, you need to checking this out. Okay, so outlet size, outlet size, outlet size, outlet size, identifier, uh, copy this out and let's making it outlet size. So copy this out and making it out here. Yeah, we can making it 6, I think so. Yeah, you can see medium, small, and the high. Yeah, it don't have any problems. Okay, and my outlet size is also safe. Let's try to do the same thing for the outlet location type. Yeah, I know it's boring. Yeah, we need to checking this in the whole data. Is there any problem in the data? Otherwise you can't, okay, you can building on robust machine learning model. Is the work for the data scientist. As a data scientist, I need to do this out. So the last one is called the outlet type. So I can copy this out and it's called the outlet type. Okay, outlet type, and now copy this out and paste it here. Okay, you don't have any problem. So let's try to increase this out. Let's say 10. Yeah, you don't have any problems on that. Okay, just we're having one problem in our item fat content. In our item fat content, it having some problems. So what I can do is simply going to replacing this out the value. So let's say data dot replace, and what I can do, we can replacing this item fat this item fat content, item fat content with having two columns. So first one is called the low fat. So low fat should be changing with the low fat. I mean, here you go, you can see just white. We can copy this out from here, and so we can checking this one again and again. Okay, so here you go, and paste it here, and here you go. So the low fat should be the low fat, and also having problems on the LF. So this should be also the low fat, low fat. And now for the REZ, it should be the regulars. So let's say REZ, there should be the regular. So regular, okay, regular, this one. And now what I can do is simply going to making the in place equal to true, so that it's not creating here the extra column. Okay? So let's making it in place equal to true. Okay, that's it. Now let's making it is here inside my data. Okay, data equal to data to replace, and each, yeah, I think so they'll replace. So we can, yeah, we can do the same thing. Non-type update is not subscribable. That content is not working on here. Why should we replace it here? I think we need to run it from here. Okay, I think I need to run it from the beginning because I replace it. Item fat content, just wait, item fat content, the low fat, it could be low fat. Okay, I think I need to run it from the beginning. Here you go, just wait, it will try to do this out. I hope so. Yeah, here you go, yeah. Now you can see it's working fine, just having some problem on that. And now you can see it's having just low fat and the regulars. Okay, that's really replacing the whole data. Okay, now what I can do, see, we having some categorical columns, we having some categorical columns, we have some categorical columns. So what I can do, we're simply going to copy this out first. We need to do the label encoder for that, do the label encoder. So those are my columns, we need to handle this out. So what I can do, we can do the label encoder. So label encoder is nothing but making this categorical data in the numerical data, just have replacing this categorical data with some numerical, just like 1, 2, 3, like that. So let's try to do the label encoders. So go on the heading and make it okay, and the label encoders. Fine. So now what I can do is simply going to import it, our label encoder. So for that, what I can do, we can simply going to import it from sklearn. So let's say from sklearn dot preprocessing processing. I'm going to importing here the label encoder. So label encoder, as well as from sklearn dot model selections, model selection. We're simply going to be importing here the train, test, and as well as split. Okay, train, test, and split. Okay, that's the thing we needed. Now what I can do is simply going to creating here one encoder objects, and after that we can fit with our data. So what I can do is say encoder equal to label encoders, label encoder. Okay, that's our label encoders. So it's created, now what I can do is simply going to fit with our data. So let's say data equal to let's say encoder, encoder dot fit transform. Which data, uh, this data, let's say this data, the item identifier. So in this data we're simply going to fit transform. So let's say transform, and after that what I can do is simply going to put our data, and that's our data. Okay, our data identifier. So using this we can do the fit transforms. So let's try to do this all of them. Okay, so item fat content, copy this out, paste it here, item type, item type, item type, outlet identifier, outlet identifier, identifier, outlet size, outlet size, outlet size, outlet location type, and this is the location type, and last one is called outlet type. So we can copy it from here and simply going to paste it here. Okay. Okay, that's the encoder. Now if I try checking this one, data.head, then you can see all the data should be converted in numerical columns. Okay. So this is how you can actually using here the level encoders. Okay, so now it's time to split the data into the train, test, and split. I mean training part and the testing part. So for the machine learning model, building the machine learning model, we have the 80% for the training data and 20% for the testing data. So now what I can do is simply going to using here the train test split for dividing our data set into the but before that, it also divide our data set into dependent and independent features. It's like X and Y. So let's try to do that. Well, so now what I can do is simply going to using here, that's X, should be capital X, equal to, let's say, K, taking for the data. So let's say data dot drop. And after that, you can using here the columns, okay, columns equal to just dropping the target columns. You have the target class is nothing but the outlet, item, outlet cells, which one you to predict, okay. And let's making the X is equal to 1 in the column axis. And that's my X and that's my Y. It's nothing but data of the this one. Okay, let's giving here one heading. So let's say splitting data into train test part. Okay, let's make it. Okay, let's making it and let's making it the heading. Okay, that's fine now. Okay, X and Y converted. Now if you're trying to checking the shape of the X, let's say X to shape. So this is how the shape is look like. And if the checking the shape of the Y, let's make it here Y shape. Oh yeah, fine. Now let's try to divide that data set. So let's say train test split, and let's giving here X and Y, as well as give me the test size. Size is equal to 0.2, and just giving here random state is nothing but the 42. Okay, and let's make it inside the X train and the X test. Y train and the Y test. Okay, X train, Y train, X test, Y test. Fine. Now we need to using here our machine learning model. So which kind of model are you going to using here? Because this is a regression problem, so you can using here the loss regressions as well as decision tree regressions. You can using it here. But for this case, I'm simply going to using here the XGBoost. This XGBoost regressor, I'm simply going to using it here. So for that, what I can do, we need to also import it here. So you can import it from the XGBoost. So let's say import it. So it's better you can import it here. Okay, so let's say from XGBoost. Okay, we can importing here the XGB regressor, and after that we need to also import here the matrix for sklearn dot matrix is simply going to importing here. Okay, you can import it from here. Let's say from sklearn I'm going to importing the matrix. Okay, matrix. Okay, XGB is not BG. Okay, now it's fine. So we can creating here one instance for the regressor. So what I can do, you can simply going to create this out. So let's say XGB regressor, and this one, and that's my model. So let's say model. Okay, and after that you can using here model dot fit with my X train and my Y train data. Okay, we can also do the predict. So let's say model dot predict, and after that you can passing here my X test data. So this is my predictions, also called Y predictions. Okay, so that's my predictions. So what I can do, you can using here the matrix for calculating the RT score. I mean root score. So matrix dot R2 underscore score root score value. So let's try it for the Y test and the Y predictions. Okay. So 50% is nothing but the root score value. Okay. So let's checking the data. Let's taking the data. Let's say data dot info. Okay. So that's our data set, how it look like. Integer 32, float 64. So let's try to creating here one predictive model, but let's taking some samples. So that we can copy it. Sample 4. Yeah, we can taking the samples. So what we can do, we can simply copy this out. Copy this out, and I'm going to paste it here. Those are the value I'm going to using it here as input. So what I can do, let's using it here input. Input is nothing but, let's say, I'm simply going to using this one. Here we go. Here we go. Just taking it from the data, and after that, I'm simply going to making it with a comma 1 and 1. Here we go. I mean the first one I'm going to taking it out. Okay. So I'm going to copy this out and cut this out and I'm going to paste it here. The first value. Then after that, what I can do is simply going to taking it, let's say np dot as array, because we need to convert them into the as an any array. And after that, we need to giving here my input, and all of my data type should be in a floating point number. So let's say float. You can give it here float 32 as well. So that's my input. So let's say new input. Okay, its input is nothing but the keyword, so let's make it input 1, because you can't using here the keyword in the programming language as the variable name. So let's make it predictions. Predictions is nothing but model dot predict, and you can giving here my new input. And after that, what I can do, we're simply going to reshape it. So let's say reshape, and after that you can make it into -1 to 1. Okay, reshape it, and let's do printing in the predictions. So print prediction. Okay, feature shape mismatch accepted 11, got 1 again. Okay, that's problem because of reshaping, because we need to making it 1 minus 1 mistake. Okay, well, you can see here we got the predictions. It's nothing but 1749 is the predictions. So yeah, quite similar. Okay, you can using here another one. Let's using this ones. Let's copy this out, and again I'm going to paste it here. So same thing, comma, and here we go, comma, then comma, and this also. Let's copy this out, cut it out, let's paste it here. Let's use this one. Now you can see got here 5790. It's nothing but 7370. Quite okay, quite fine. Yeah, if you're trying to getting here the more accurate types of values, so what you need to do, you need to also fine tune your model. Okay, I mean hyper tuning your model, so you can get here some exact output. Yeah, that's also good. That's not bad. It's like 100. Okay, yeah, that's also good. We got here some kind of predictions we got. Okay, that's fine now. So what I can do is simply going to save the model. So let's say import pickle. Let's save the model. So let's say pickle.dump, and after that you can using here the model. So that's my model, and then we can using here open method to save the model file. So let's say model.pickle file, and after that we need to giving the mode. So let's say wb. I hope so it's saved in my directory. You can see here model.pickle file. So now using this model.pickle file, you're going to be creating here what web applications using the Flux framework. And after that, you're going to testing it out our this predictive systems, and into checking this is there getting here value or not. So let's go on here and try to creating here the applications. Well, so it's now time to creating here the web applications using Flux, and that's the code for that called app.py. So I'm simply going to running this file by clicking this run button, and after that, we are going to discussing about the interfaces, how the interface look like, and how can you building these full applications using Flux and uh, Python. Well, so that's our application, how it look like. You can see here it having a heading called Big Mart Sale Predictions using machine learning. And you can see here input all features here and identifier is text box, also text box, text box, text box, text box, text box. And also you can see here outlet stabilized error. In a error version, you can increase or decrease the error from here. Okay. So also having one predict button. So when you're clicking this predict button, it will give you the predictions based on your input features. So now we're simply going to building these applications. I mean, how can you building these applications? We're going to discussing about that. Okay, so this is the code for that called the app.py. This is the server-side code. So I'm simply going to kill the terminal here and see inside that first you input in a flux, and after that you input here the flux and as well as the request and random templates. So inside this random template, it will try to rendering one template, which is nothing but my website template. If I go inside this template folder, you can see here it having a file called index.html. So this is a HTML file, I mean my designing file. So here you need to designing and you're going to taking this input using this HTML file. And also inside this section, you can see here we have the model file called model.pickle file that is saved in our Jupyter notebook. Now see in index.html we are having one title called Big Mart Sale Predictions using machine learning. This is my application title and having some style. Inside this style tag, it having the all of the CSS file. Okay, for the designing purposes. Now let's talk about the important part one. See, we having one from. This is the important one. Inside this from, we having one action called predict. Action called predict. And also you can see a Big Mart cell. This is an heading and also input all text here. You can see here just to avoid this is to text. Just this ones is simply going to do the designing part here, but the main part is inside the from tag. So inside the from tag, you can see here actions is nothing but a predict. Okay, so this predict is coming for my app.py. If I see that this is route is nothing but predict. So that's mean when the users clicking the predict button on the website or the web page, it will directly go to this from and taking the input from the users. And after that, our machine learning model is started predicting here on the output. That's mean action is nothing but predict. It means calling these predict functions. Okay, we'll go on the later on, but first discuss about that. And also you can see here method is nothing but post method. So there are two types of method are available called get method and a post method. So this is a post method because you're going to take an input from the users, then you give me the predictions. Then you can see here it having a label called the item identifier, and also you can see input type is nothing but my numbers. Okay, and also input type is nothing but number, and also you can see step is nothing but any. Step is nothing but any means you can giving here any kind of number, just like the floating point number or the integer number you can give it here. If you just removing this step from this input, okay, from this input tag, it will give you error. That's mean not taking the input for the floating point number. See, in our data set having some value which one is regarding the floating point number, so it cannot giving this floating point number as well as the integer numbers. Okay, so what I can do is simply going to giving here step equal to any, so which one taking the floating point number as well as the integer number. Okay, now you can see here also giving here on names. You can see here the item identifier, the item weight, the item fat content. So using this one, what I can do, you're going to taking the input from the users. Okay, now those are the columns is the symbols. All of the columns actually give it here based on the levels. And also you can see here when you're clicking this button called submit, this form is taking the data from each of the column and give it the data in our machine learning model, and based on this predict route. Now if I getting these predictions, we're simply going to taking these predictions from our server side and pass it inside my web pages. So when I click in this predict button, it will get in this data, I mean getting the predictions from my app.py, and after that it will show you this predictive cells and as well as the predictions. If I go inside this add.py, see, first we importing here the flux and import the flux request and as well as the render template. Then you input here the numpy as a MP. Then import here the pickles because into loading the our models that you actually train it in before. Then you have the import scalars. I don't think it is needed. And after that, you're simply going to load our model file in the read mode. Okay, read mode. Then after that, creating here one applications using app equal to flux underscore underscore name, and simply going to creating here our initial route. Which one is the initial route without the values? Okay, which is going to render in the first time. But when the user clicking on the predict button, in order to giving all the values, it will give me some predictions. That's going to calling this route called the predict. Okay, so when the user clicking the predict button, clicking this predict button, it will go to this route, and this route, the method is nothing but the post method. If the method is post method, it will taking all the value from the each of the input column or the input box. Okay, and after that, what I can do is simply going to pass it inside my numpy array, because you need to convert them data into one numpy array, and after that it also reshaping the data, and after reshaping the data we need to passing our predict functions. Okay, so you can see predict function and it will give me the predictions. You can also painting it here, and then after that is simply going to passing this data in our templates as just like the argument, or you can say parameters. Okay, you can see here the predictions is nothing but the predictions. So if I taking this ones, after taking this one, if the prediction is happening, we simply going to taking it out and try to show it out in our applications. So this is how our application is look like and how it will actually work. So what I can do, I'm simply go on my app.py and I'm simply going to run it from here. You can also running it from here, just like on here, and click on terminal and new terminal. You can also running the application from here as well. As if you're trying to building this full applications, the full application, okay, I think here is some problems. I have to save this out. Okay, if you're trying to build this full application using Streamlit, you can also do this out. Okay, you can also do it out using Streamlit. It's super easy to creating the web application using Streamlit also. So what I'm gonna do, I'm simply going to go on here and try to follow the link. You can see follow the link, and now you can see we have in the input all the features. So now what I can do, I'm simply going to giving him some value, let's say 250. See, we also giving him the integer as well as the floating point number. So let's give him the floating point number. That's a 6.89. Just simply taking the input from the data set and trying to giving it here randomly. Okay, so flat content, let's say give it here 1, and item b, let's say 0.13. Okay, and item type, let's say 193. Let's say item type, let's say 13, and item mrp, let's say 193.9820, and outlet identifier, let's give it here 8, and our year should be, let's say 1997. Okay, and outlet size, let's say 2, then 0, then let's give it here 1. Okay, just for the testing purpose, I will taking this from the data set. Okay, and let's click here to predictor. Now this is our predictor cell, how the predictor cell actually look like, and this is how our application is look like and how it will work. So you can giving here your values in our input boxes, and this application gave you the prediction scores. So this is how the full application look like, and hope so you enjoy this full tutorial, and make sure to subscribe to the channels and don't forget to hit the bell icon for upcoming videos. You can get also notified for that. So that's it for today now. Thank you and bye bye.